So you can see the circuit which is shown here, the diode is in the input circuit of the operational amplifier, and in the feedback I have the 1K resistor. Previously for the logarithmic amplifier they were interchanged, the diode was here and the resistance was here. Now for anti-logarithmic the diode has come here and the resistor here, and there is nothing else except for the op amp. So when I give input voltage, I give input voltage for the DC voltages from the millivolt source which we have used even earlier, and the output can be varied in 100, 200 etc. millivolts. I have now kept it in millivolts, 1, 2, 3, 4, that means this is in 100 millivolt, this is 1, 2, 3, 4 means 100 millivolt, 200 millivolt etc. This is the minimum position. So the input voltage is actually connected at the diode. You can see the circuit here, the diode is at the input circuit and this is the op amp, and in the feedback I have got the 1K resistor. From the color code you can see brown, black, red, this is 1K resistor. So this is a very simple circuit, and now the output is connected to the pin number 6 to a multimeter. As you can see, the multimeter now reads 1.55 or something volts when I give 100 millivolts. So you get a very large output. Previously if you remember, when I changed from 100 to 200, 300 millivolt, it was changing from 0.48 to 0.51, 0.53, it was changing very slowly the output compared to the input. Now what is happening, for a change in input there will be a very large change in the output, exponential increase in the output, because it is a anti-logarithmic amplifier. Now to see what is the input I have given, I take the multimeter and connect it at the input terminal. When I connect the multimeter at the input terminal, you see the multimeter, it shows 1 volt, it shows 1 volt. Now I will make it 100 millivolt. So this is actually, yeah, so this is 0.1 volt, that means 100 millivolts. Now when I have 100 millivolts at the input, I take out again and connect the multimeter at the pin number 6 of the op amp, and you can see it is around nearly 1 volt, 100 millivolt comes nearly around 1 volt. Now when I increase to 200 millivolt, when I increase the input voltage to 200 millivolts, I get about 1.03 or something. So I change to 300 millivolts, now it is 1.12 etc. It has gone to volts now, and when I go to 400 millivolt, it is 1.17 etc. right. So if you actually take the output, it will be related to the input through the logarithmic, that means logarithm of the output voltage will be equal to the input. It is a reverse operation, that is what we should remember. Therefore output voltage will be exponent of some value into the input voltage. That is what we already showed when we discussed the corresponding equation to this. So this is the anti-logarithmic amplifier, where the diode is in the input circuit and the resistor is in the output circuit. We are making use of the relationship of the current through the diode, which I is equal to I naught exponential. So this is what is being made use of in this configuration for generating the logarithmic relationship.